Hello, can you hear me? Yeah, if you're using a different account, good morning. If you're using a different account, just just like chat your name so that I can take attendance later. Mm. Also, I think um hello everybody. We're gonna wait a second. I forgot to send out a message from Canvas, so I'm gonna do that before we start. Hi Jalen. Hi Melissa and Aiden and Nick and Emily and Shelby. Hi. Let me send out a Canvas notification really quickly and then we'll start. Are you ready for ASMR today? Just kidding. I hate that stuff. I know he disliked my stream. I'm used to people disliking my class, so it's okay. Yes, you will need your book. We're gonna be taking notes just like normal. So you will need your book. I think that we're on page 40 today. 40. I am tired. I got woken up by an earthquake today. Yes. There is a warm up for you to do. I'm not gonna have any way to check them, so you have just your own accountability to do them. But yes, yeah, it's been already a long day and really early. You want to see my dog? Wayne, come here. Come here. Come here. Come here. Jump. Do you see my adorable dog? She's so cute. She's my favorite. Hi, Christina. This is what we're just living through this technology for, is the pet content. Thank you. Okay, get down. Yes, we're using our green book. Let's do math. Alrighty, warm-ups. So, these are special right triangles, and these are going to be important. Special right triangles, we have a 30, 60, 90 triangle and a 45, 45, 90 triangle. So just as a reminder, I have this page open because I'm prepared. Nope, this one. 45, 45, 90 triangles have two of the same side lengths, and then the hypotenuse is going to be whatever that is times root 2. So if you look at our warm-ups, we have that the hypotenuse is 10. So in order to go backwards from the hypotenuse to the side, instead of multiplying by root 2, you're going to need to divide by root 2. So this is a divided by, oops, not 2, by root 2. And we're not going to get a decimal because I don't want decimals today. So we're going to say this side, let me erase my circle so I have room to write it. This side is 10 divided by the square root of 2. I'm not going to turn on donations. I do not need your money. And so is this side, because they're the same on a 45, 45, 90 triangle. On the other triangle, on a 30, 60, 90, the hypotenuse is twice as big as the short side. So let's do that first. I cannot do pages today. Okay, so it's twice as long as the short side. From 10 to this side, it's going to be divided by 2, which will be 5. And then from the short side to the, oh, for my dog. Okay, that makes more sense. She would appreciate it. For the middle side, for the other leg of that triangle, you multiply the short side by the square root of 3. So, there we go. We multiply 5 by the square root of 3, and we get 5 root 3 for this side. That's okay. This is the warm-up. Somebody asked if it's going to be on Canvas. Yes, I will put it on Canvas later. Yeah. Yeah, if you have some sort of conflict with another class, just watch this later. You'll still get all the points you need. Okay, that's our warm-up today. And it has a lot to do with our notes. So we're on page 40. If you're not there already, let's get there. 8-3. Yes, you need your notebooks. Okay. So 8-3 is about the unit circle. So the unit circle is going to come back like a lot in your life, especially next year. So I wanted to talk about the unit circle. Remember, we learned about the unit circle very briefly when we first learned trig. We used it sort of to talk about what the trig functions actually do when they're used to find the side lengths of triangles with the hypotenuse of 1. So we're going to just dive into that a little bit more because once you sort of are familiar with the unit circle, it can sort of shortcut some of the math that we're doing. So we have some special right triangles. This is the first bit of our notes here. There's two 30, 60, 90s. And there's one 45, 45, 90. So for the first, the leftmost, hey, I have a laser pointer on that triangle. We have a hypotenuse of 1. So we're going to use, again, the special right triangles that we used before to figure out what the side lengths of these triangles are. Okay, so these triangles will fit into our unit circle because they have a hypotenuse of 1. So they're like those triangles we did on the first day of notes when we on this unit. But these are specifically special right triangles with the hypotenuse of 1. So for this first one, the relationship between the hypotenuse and the shortest side of a 30, 60, 90 is that you multiply the short side by 2. So in order to go the other direction, we need to divide that number by 2. So we'll be dividing by 2 to get this side. And again, let's not do, whoa, that's not half. There you go. Let's not do decimals today. Let's just do fractions because that's usually how we see the unit circle. So we're going to just do fractions. So the vertical side of that 30, 60, 90 triangle is going to be 1/2. And this side, remember that you take the short side of your triangle and you multiply it by √3 to find the other leg, the longer leg of the 30, 60, 90. So you multiply this by √3 to get the other side, which gives us √3 divided by 2. Good, good. Okay, so for the 45, 45, 90 triangle, remember what we just did in our warm-ups where we have to take the hypotenuse and we divide by that √2, because we know that from the from the leg of a 45, 45, 90 triangle to the hypotenuse, we multiply by √2. So we need to do the opposite to go from the hypotenuse to the side length. So we need to divide 1 by the square root of 2. 3, there you go. Divide 1 by the square root of 2, which gives us 1 over √2. We are just going to leave it like that because we do not need decimals right now. And then the two sides of that triangle are the same, the two legs. So we know this is also 1 over the square root of 2. The third triangle there, the side lengths are going to be the same because the hypotenuse is still 1. They're going to be the same as the first one we just did, but it's just tipped upward, and you will see why we need this triangle in a second. But again, from the hypotenuse to the shortest side of a 30, 60, 90, you divide by 2. Because usually we're multiplying by 2 from the shortest to the hypotenuse, we multiply by 2, so we're going the opposite direction. So we get a 1/2 on this side, and then we multiply by √3. I don't have anywhere to write that. Multiply by √3 to get the other leg, which gives you √3 over 2. So again, same side lengths, it's just tipped up on its side. Okay, for this next little bit, stay with me because we're now going to put these triangles that we just found, these side lengths, we're going to put them in the unit circle. So we're going to look at this image down here. It's just a quarter of a unit circle. So here's our unit circle. It keeps going around there. And we just put all three of those triangles inside of the unit circle. Notice that they're all nicely fit inside because their hypotenuses are 1. So our unit circle with the radius of 1 fits it. Yeah, Jalen, fourth period is, I'm doing this only once. So yes, theoretically this is everybody. Only there's 30 of you, so it's okay. The rest can watch it later. Yeah. Okay, what was I saying? Oh yeah, so we put those three triangles inside of our unit circle. And what we're gonna do is we're going to figure out the coordinates of these points right here. So the coordinates of those points, normally when we're finding coordinates, and I'm just gonna write this up here really quickly, when we find coordinates of a point, we find the x value first, which is this length, and then the y value, let's get a different color, and then the y value, which is this length, to figure out where that point is. So you end up with a point that says, colors, the x value of that point, and then the y value of that point. There you go. Normally when we find coordinates, we find the x value and then the y value. So on these triangles, the coordinates of these points are going to be the same. They're going to be that horizontal distance and then the vertical distance, which you might notice is actually the side lengths of those triangles. So for the first one, the one that I just highlighted in yellow, we're going to use the side lengths of that triangle as sort of the coordinates. So the horizontal distance and then the vertical distance are going to give us that point. It's going to give us x value, y value. So we're just matching this triangle to the one we did this already. We found the side lengths of this triangle up above. This one is root 3 over 2. Nope, it's not. I was looking at the wrong one. This side length, and again, we're focusing on this triangle here. I know that we have 3 overlapping triangles. But on this triangle, the bottom is 1/2, and this side length is root 3 over 2, which means that the coordinates of that orange point is 1/2, comma, root 3 over 2. We're using that horizontal and that vertical distance to find the point on our unit circle, like on the graph, on an XY coordinate plane. Sorry, I'm reading your comments. Sorry that you can hear me swallow. That's probably really gross. I'm wearing AirPods because they make the sound better, but they also are very close to my self, so you hear a lot of things. I'm sorry about that. Okay, so we are going to now do the same thing for the other triangles. Only I'm not going to label the side lengths because if I do that, it's going to be super confusing when you look at this later. But that 45, 45, 90 is the middle triangle that's overlapping there, and both of those side lengths are 1 over root 2, which means that our coordinate point is 1 over square root of 2, comma, 1 over square root of 2. This is the x value, and this is the y value because we're using that horizontal and vertical distance as the sides of the triangle. I'm not trying to flex on you. My parents bought them. I don't have money. Yes, okay. So the third point and last point on this unit circle is the sideways 30, 60, 90. And the point for that one is going to be, let's see, the horizontal distance on this triangle, the horizontal distance meaning this bit right there, is root 3 over 2, and then vertical is 1/2. So our point is going to be root 3 over 2, 1/2, because we're going over root 3 over 2, up 1. Okay. Hopefully that makes sense. We are just you're using the triangle's side lengths to figure out the coordinates of those points. So coordinates of on the coordinate plane, we're using horizontal and vertical distance. Okay. Next, we're going to, so you might remember from the first, sorry, I keep getting messages. I'm sorry that I just like have a seizure once in a while. Okay. Okay, so you might remember from our first notes, and I might go back there actually. Let's do that. Hang on. Just so you can see them. No, that's not what I want. Okay, yeah. Okay, so we're gonna go back to the first notes we did on trig, and I'm just going to remind you of some things. So remember how in this picture, the cosine of the angle, the reference angle, will give you the horizontal distance, and the sine will give you the vertical distance. So notice that there are these coordinates that we didn't really pay attention to last time, which is good. But there are these coordinates that say cosine theta, sine theta, which is what we're now going to deal with. So we're saying that horizontal and vertical distance are giving us the coordinates of that point where that triangle hits the circle. So we're going to identify, so notice now that we have cosine, we have sort of identified where those are coming from. Remember that cosine gives you the horizontal distance and sine gives you the vertical distance. So in a coordinate point, you have the x value and the y value for horizontal distance, vertical distance. Horizontal distance and vertical distance. So cosine gives you the x coordinate of that point, and sine gives you the y coordinate. And vice versa. The y coordinate is the sine of that angle, and the x coordinate is the cosine of that angle. Tangent is funny. Tangent is a ratio of two of them. So we'll sort of talk about how we would use tangent in a second. But just know for now that to get the tangent of the reference angle, you use the y value, divide the y value by the x value. So it's a ratio of y divided by x. Yes, for those of you asking, so now that I have more of you here, I plan on holding a lot of like study group sessions on Google Meet that are smaller so that we can sort of have more of a interaction, and it's just for whoever's available and ready to work on their homework. And we just sort of hang out and work on homework together, slash I will answer your questions if you need it. So I do that after. This is just for like notes so everyone can have them, and then we'll do Google Meets after. Okay, so again, cosine gives you horizontal distance, sine gives you vertical distance, and tangent is the vertical over the horizontal. So it's a ratio of the sine over cosine. So here's what we're going to do. And I know this is going to seem intimidating, but I promise it's not. On the next page of your notes, you have this giant, crazy alien looking circle. But I want you to notice that as you zoom in here, this quarter of the notes is exactly what we had on the other page. It's just three triangles. It's a 30, 60, 90, a 45, 45, 90, and another 30, 60, 90 triangle in one quarter of the circle. And it's actually repeated on all four quadrants of our plane. And so on this unit circle, we're going to indicate the reference angle for each of these triangles, because that's going to be what the helpful information, where the helpful information is coming from. So on this triangle, and I will, let's see, use a laser pointer. On this triangle is a 30, 60, 90, and this angle right here is 30 degrees. And I'm going to not write it there because it's going to be super confusing to write all of the angles on top of each other. So instead of writing that that's 30 degrees right there, I'm going to write it on this line. So I can remember that that's where that 30 degrees is coming from. On this 45, 45, 90 triangle, the reference angle in the corner is 45 degrees. This angle right here. But again, I don't want to write it there because they will get all piled up and I don't want to confuse myself. So yes, alien circle. So I'm just going to write it on the line so I can tell that that line is going to be pointing towards the coordinates that I'm going to be using. So 45, 3 different reference angles here. Yes. So we have 3 reference angles, and we're going to sort of keep going and fill out more of these reference angles. And I don't want you to get super confused about where these are coming from. All we're doing is we're saying that this is a circle, and we're starting from this horizontal line on the positive, in the positive x direction, and we're recording angles as that line continues to go around. So the radius sort of is going to determine what our reference angle is. So the vertical line is going to be a 90 degree because the reference angle, the one in the corner, is 90 degrees. So here's our 90 degree angle. And then we're going to keep going. So I don't want to make this too confusing for you. I don't want us to like think too deeply about where these lines are coming from, but just remember that this 60 degree angle from the other side is sort of, we're going to keep going with that angle, and we're adding like 30 degrees and then little pieces as we go. So again, I don't want you to get too confused about this part. All this is going to be in the end is a reference for us so that we can use this reference when we're trying to find values of sine and cosine, or the angles for values of sine and cosine. This is going to be a reference for us. So this angle ends up being 130 degrees because again, it's from the horizontal x-axis. We're saying that whole angle. So that's 130 degrees. This one's 135 degrees. I'm making sure that that's right. Oh, not 120. I'm sorry, that's why that's wrong. I was like, that does not seem right. This is 120 degrees. And then the middle one is 135, and this is 150 degrees. And then that horizontal line would be a whole straight line, so that's 180. Yeah, thank you for correcting me. It's 120. Then we have 210, 225, 240 degrees, 270 degrees. So this might remind you a little bit of those when we were drawing triangles to find inverse sine. We had to use these sort of angles in a circular pattern. Degrees. 30 degrees. So that horizontal line also doubles, so it's 0 degrees, but it also doubles as 360 degrees because we have come full circle, and so now we have 360, hi Kyla, degrees worth of angles here. So now that we have those reference angles on our unit circle, we're going to fill in the coordinates. And these all come from, again, this is just like multiplying what we had on the other page by 4 times. We're just using that horizontal and vertical distance to find these coordinates. So for now, I just want you to copy down these coordinates and then you'll start seeing a pattern from the 4 quadrants. So we have root 3 over 2, comma 1/2. Again, this is the same as it was on your other page. I'm just copying it down here. This is 1 over root 2, comma 1 over root 2. And this one is 1/2. Remember that this is kind of the reverse of the other 30, 60, 90. It's just that the horizontal and vertical values are switched. I might want to write those smaller so I don't get crowded. Okay. And then we're going to keep going. We're going to fill in the other quadrants as well. But look for these patterns. So notice that we're sort of mirroring these, sorry, I cannot say that word, mirroring these quadrants across the axes. So they're mirrored, they're the same, but the signs change. Because notice that in this quadrant, we have positive x values and positive y values. In quadrant 2, that's quadrant 2, the next one we're going to do, the x values are now negative because we're going backwards on the x-axis. So you end up with a negative x and a positive y, which is going to be important because that's all that we're changing. We're mirroring our same numbers, but the signs are changing depending on which quadrant you're in. So instead of having our 1/2 and root 3 over 2, we're going to have negative 1/2 and root 3 over 2 because we're changing the x value to be negative. I'm going to rewrite that because it was really messy. I'm sorry. We're going to have negative 1/2 and root 3 over 2. And this one, instead of being positive 1 over root 2, it's going to be negative 1 over root 2 and positive 1 over root 2. And then last we have negative root 3 over 2 and 1, positive 1/2. So notice that those are the same values, just mirrored over that y-axis. But now we have negatives on the x-axis. Yes, please write down those angles. I know I'm super late reading these comments because I was focusing. Also, yes, I will still do study group Google Conference things. I will announce those on Google Hangouts, so if you haven't downloaded it yet, please do that because that's going to be good. That's how we're sort of communicating in these weird times. So I will announce on there when I'm doing a study group, and you can just join whenever you are available. Okay, so notice we're mirroring. We're going to do the same thing again. We're mirroring now upside down, but the third quadrant has negative values because we're backwards on the x-axis and down on the y-axis. So we're negative. So we use the same values, but dang it, I keep running out of room. There you go. Same values, but now both values are negative. So we have negative root 3 over 2 and negative 1/2. And both of our 1 over root 2's are going to be negative. And you know what I thought? I thought I would have better handwriting when I was actually writing on a desk. It's wrong. I do not have better handwriting. It's just the same. And then the third one is going to be negative 1/2, negative root 3 over 2. So we're seeing the same numbers over and over again. They're just changing signs and places. Okay, last quadrant is negative on the y values and positive on the x values. So sort of the opposite of quadrant 2 is quadrant 4. And so again, we're mirroring. We have a negative, positive 1/2 and negative √3/2 and positive 1/√2 and negative 1/√2. And last we have negative, trying to match my other one, negative, not negative, positive √3/2, negative 1/2. So notice that we're just adding the right negatives and positives, and otherwise we're just mirroring. Thank you for saying your names. I will take roll when we're done taking notes. So if you haven't yet, say your name. If you're watching this later, just comment with your name so that I know that you watched it. I'm most likely gonna check that tomorrow, so hopefully it's sometime today that you're watching it. Okay, so we have all of our coordinates labeled, except for these ones, which are actually the easiest, because that is just, let's see, the horizontal distance is 1, and the vertical distance is 0. And this point, the horizontal distance is 0, vertical distance is 1, so that's 0, 1. And the rest are the same, just mirrored, -1, 0, and 0, -1. Those are sort of our axes points. Now we're going to do a lot of highlighting because I love to highlight things, and also it's very good for your brain. So let me just remind myself how I highlighted. So I have sine as blue and cosine as yellow or pink. Hello. Cosine is blue, sine is pink. So I'm going to highlight all of my cosine values, which is the x values of all of these coordinates, in blue. Because again, we're using this as a reference for, it makes it easier to find values of sine and cosine. There we go. Okay, and also highlight, that's going to be bad on mine because I wrote it in orange. But highlight the same x and y values on your axes points because those are also valid and important. So cosine of those reference angles is in blue and sine of those reference angles is in pink. Yes, the pictures of the notes are going to be on Canvas still. Also, this video will be linked on Canvas, so you'll have both. Okay. Okay, so here's why this is helpful. Here's why we did all that labeling. Because now without doing any calculator math, we can find exact values for all of those really common angle measurements for sine and cosine. So for example, let's just take 30 degrees. So on our 30 degrees, this is our 30 degrees. If we wanted to find cosine of 30 degrees, you know what that is? It's √3/2. If we wanted to find sine of 30 degrees, it's 1/2. And you can check that on the calculator. It'll probably give you decimal values, depending on what calculator you're using, but you can check it. Cosine of 30 degrees is √3/2, and sine of 30 degrees is 1/2. And you can do that for any angle. So if you wanted to do 120, cosine of 120 degrees, which is right here, 120, cosine of that is -1/2, and sine is √3/2, sine of 120. And this also works in the opposite direction. If you know, for example, that sine of some angle is, let's find one. Sine of some angle is -1. You look through your chart and you find a sine value of -1, which only occurs here. So you know that the angle they're talking about is 270 degrees. There's some math-based homework questions on that. So again, if you are doing the reverse, if it says cosine of theta equals -√3/2, you look through your chart for a cosine value of -√3/2 and find, oh, hey, look, that's cosine, and it's connected to this angle, which means that that angle must be 210 degrees. So that's how this is helpful. This is just a reference for you, and it's very nice. You will one day, I'm not going to scare you, but this is for next year problems. You'll probably end up wanting to memorize this whole thing, but really, like we sort of discovered, it's all kind of like a mirror of each other, and so it's pretty easy to replicate. But one day in your eventual future, you might have to remember this all. Oh no, Eli's making a table. Okay. If you have questions, specific questions right now, now's a good time to put them in the chat. I can answer questions. While I answer questions, I want you to try doing a couple of these problems down below. Notice all you're doing is looking for, so I'll do this first one just so that you know what you're doing. So it says sine of 135 degrees. So you look on your chart and find 135 degrees, which on my chart and supposed to be on your chart should be right there. No, that was 100, the same numbers, dyslexia. 135 is here. There you go. So you're looking for the sine value of that angle. So sine again is the pink one. So sine of that angle is 1/√2. So that would be your answer for that. 1/√2. So yeah, I will answer some questions, and I can't answer all of those questions. Math questions. Math questions are good. The purpose of life is the number 42. Anybody know that reference? It's an old movie. So Christina, if you're asking about, wait, I'm just checking. Okay, I don't know what you're talking about, Christina. Oh, why does the pattern go? Okay, so the pattern again comes from the special right triangles. So if you missed that part of the lesson, go back and watch the special right triangle part. The reason that it doesn't go in like a circular pattern, which is probably your question, like why doesn't it repeat in a circle? It's because we're mirroring instead of going in a circle. So those points are mirrored on the upwards, like on each quadrant. So that's why the coordinates are also mirrored. They don't go in like a circular pattern, which I know is kind of bothersome if you want them to be in a pattern, but it's mirrored instead of the other way around. Brendan, we will not only use these angles, but for your homework, these will only be the angles that you'll do. So like 37 degrees, like if you were doing sine of 37 degrees, which is not on your chart, which is what he's asking, you would just use a calculator and get a decimal. So there's not going to be a question that's like, find the exact value of cosine of 37 degrees, because that's not on the unit circle. You know what I mean? Exact value meaning not a decimal. It's a good series. Yeah, so there's the only triangles that are in the unit circle are special right triangles. which is why there's only those angles. And those are like honestly the most common ones you'll ever see, actually, the ones that are on the unit circle. You're asking about number 2 being 0. Okay, so we're looking for a cosine of 90 degrees, which is here. Cosine of 90 degrees, yes, is 0. Okay, I'm gonna go down and start doing these. Cosine of 90 degrees, you're right, would be 0, not 0 degrees. That's not what we're doing. Sine of 210, so we're looking for 210 is right here. Sine of that one is going to be negative 1/2. Sine of 210, negative 1/2. Negative 1/2. Cosine of 120. Cosine is going to be negative 1/2 also. Oh shoot, I was using the wrong pen. Cosine of 120 is also negative 1/2. Okay, so here's the question. Now we're at tangent. And remember how we said tangent is a ratio of the x and the y values? Sorry, reading chats. Hang on. Oh, Christina, the square root of 2 over 2 is another way to write 1 over root 2. So if you learned the unit circle elsewhere, or if you've seen it elsewhere on the internet and other places, she's asking why is it not square root of 2 over 2 instead of 1 over root 2? Those two are actually equal. One is just the rationalized version of the other. So you're right, both are correct. Okay, bye, Tom. Yeah. Okay, so for tangent, we have to do a little bit of division work. So here's why that's not scary, and I promise it's not. Takes a little bit of just sort of common sense math. So tangent of 270, let's find 270 first. 270 degrees is right here. So tangent, if you want to go back to your other page, tangent is the sine value over the cosine value. So y over x. So here's the issue. Here's the point we're looking at. Y over x would end up being negative 1 divided by 0. And we all know that dividing by 0 is what killed all the dinosaurs. We don't do that. We can't do that. So this is undefined. And actually, if you typed it into a calculator, that's what it would give you. It would say, nope, that's not possible. But let's do one that is possible. Tangent of 315. 315. Tangent of 315 is going to have to be the y value over the x value. But here's the thing. So I don't want you to get freaked out by having to divide those two things. Essentially, we're doing, I'm going to write it down below because it's not enough space. We have negative 1 over root 2 divided by positive 1 over root 2. And what do we know about anything dividing by itself? We know that it equals 1. And so 1 over root 2 divided by 1 over root 2 is going to be 1, except for we just have a negative in there. So essentially this is like having a negative 1 over 1, which is negative 1. So that, I did not do any fancy math. I just am remembering that anything over itself is 1 when we divide it. So I used that knowledge, and I knew that this is like, maybe I'll write that differently. I'm gonna regret my decisions here. This is like having negative 1 because there was a negative in front of our same thing over the same thing. So we would have like, if they aren't the same, you're going to have to do some fraction work, although I don't remember giving you math-based assignment questions that will make you do that. But remember that if you're dividing by a fraction, you multiply by its reciprocal. Okay, I don't know who you are, Handy Corgi, but I'm ready for your question. Yeah, if they're not the same though, Brendan, you would have to multiply by the reciprocal. So just, it's the same rules as dividing any fractions. I can do an example. Let's see. Let's do, for example, tangent of 330 degrees. The y value of that is 1/2. So you're going to be doing this division problem. 1/2, negative 1/2, sorry, divided by √3/2. So the way that you divide fractions is you use the reciprocal. Yes, you can use the bathroom. Hey, you don't have to ask. I don't have to fill out those things anymore. My goodness. Unexpected benefits. Multiply by the upside down version of the fraction. So the rules are the same as they've always been with multiplying and dividing fractions. So in this case, we would just multiply across. Once we've got the reciprocal in there, we multiply across, which would be -2/2√3, which I believe is something that MathSpace would take. If not, message me. I don't know. Okay, I'm gonna write the answer of this one in there because it's bugging me. And yeah, that's all the notes I have. So I'm gonna probably stay on the chat for like a couple minutes just to answer questions if you have them. And what else was I gonna say? Oh yes, so keep an eye on Google Hangouts because I'm going to be asking who wants to join study groups. So I will probably do a couple today. I don't know. So just tell me when you're available. I'll just sort of be on Google Meets. Just so you know, Google Meet, I don't know if it works on the app. I think you need a computer. Somebody might be able to know that better than me. But you get a invite in your email. So you would have to go to your email. If I say I added you, then you go to your email and click the button and it will open a Google Meets window. Our test is okay, so my current plan is to have you guys take the test right before spring break, which is the end of next week. So we are going to take our last notes for this unit on Friday at 10 a.m. And yeah, I also don't know how you're going to take a test. I'm going to think about it and let you know because I don't know what I'm doing either, so I really don't. It might be that I just send you the test over email and you take it, you just print it out and take it. But I don't know if everybody has the capabilities for that. I don't know. I'm gonna have to think about it, but we'll make it work one way or the other. So yeah, the end of next week, so right before spring break. We'll take our last notes for this unit on Friday. Do you need a webcam for the study session? No, you don't. Although it does help if you're trying to show me your math, like if you're like, help me on this question, I don't know what you're talking about unless you show me something. So, but if you have like any kind of camera, if you're like have it on your phone, you can just message me a picture and I can tell you how to do it over the Google Meet. So they're really low, what is the word? They're not super professional. We just hang out and do math and show off our pets. So it's a good time. Yes, it is from Hitchhiker's Guide to the Galaxy. It's a good movie. Yeah, we might have to do a poll about the testing. I don't really know what's gonna happen. Canvas whiteboard. Ooh, I don't know. Okay, he hasn't told me about that, so if he has some way to do it, I might ask him. I'm not sure. Goodbye. Oh, for a poll for the study session? Oh, whiteboards for the study session. Okay. Hmm, maybe. Maybe that will work. I'm not sure. The way that I do it is I just show you just sort of like now you can see my iPad screen and I just like do it on there so you can see what I'm doing. I think it might be a Canvas plugin or something that they're using to like write back and like draw things basically, like a whiteboard. Um, I'm gonna do a bunch of study sessions and really I don't care when you join or when you leave. But I will announce when they're starting. I will probably do one like um probably like in a couple minutes, like 11:30. I'll probably start one. Yeah, mail me it. That's good. Okay. Um, yeah, crazy times. Who knew we would have feels like the end of the world. Crazy. Anyway, stay safe. Um, I'm gonna get my dog again because I love her. Come here. Come see me. Come see me. Come say hello. Stephanie, I am not gonna stream tomorrow. Um, so it's just for the ACT class. I will stream next time on Friday at 10, and we'll do the last set of notes. She is super cute. I just gave her a haircut, so she's like a little bit rounder than she normally is. Yeah, it's gonna be on 10 again on Friday. Yep. Okay, you have homework to work on. It's called the same thing as the notes, so 8-3, the unit circle. It's gonna be due Friday, so if you are needing a study session, just let me know. Again, I'll probably start one at like 11:30, and then have a couple more today and a couple tomorrow. But just let me know if you're needing one. Um, yeah, also if you're having technical issues or if you know of somebody having technical issues, please talk to me because I haven't heard from everybody uh and I need to be able to hear from everybody. So, yeah, I'll let you know about the study session starting. Just keep an eye on Google Hangouts. Okay. Okay, I'm gonna go ahead and end the stream. Thanks for coming, guys. And again, if you're watching this later, comment below your name so that I can give you participation points for watching it. And for all of you here, I'm gonna keep track of who has been here today with me. After this, there's actually I think on Canvas they're already there. I think the notes are already there that you can look at. Okay. Okay. Have a good day, guys. I'll probably see some of you in the study sessions, which would be good if you need it. Bye.